So today we're going to be looking at how we can flatten lists in Python. And as you can see, I have some lists over here. One is a 2D list, a 3D list, and a 4D list, which you can see by the amount of brackets surrounding the elements. And I created three different functions or three different versions of the same function that can handle all three. And also down here, it works with strings. It can work with any kind of element. So when we go ahead and run this, we're going to get the flattened version of each one of these. So as you can see here, we have 1, 2, 3, 4, and we have it up to 8. And we also have the third version of this function, which also goes up to 8. And it also works with the strings. And there are many reasons you might want to flatten an array. And in Python, it does require a little bit extra code to actually get this kind of functionality. But the first thing we're going to do is start off with an empty project, and we're going to go ahead and open up the terminal and type in pip install numpy, because one of these functions are going to use numpy to flatten the array. The other two are just going to use the vanilla Python syntax. So the first function we'll create is going to be called flatten 2D, and this will be used to flatten 2D arrays. So here we need to add an input list, which will be of type list, and it's going to return to us the list that is flattened. Now, the most common way to do this is to go ahead and create a new list, which we're going to append to, of course. And what we do inside here is check for each list that is inside the list. So for each sublist in the input list, we're going to grab the element in each one of those sublists. So in sublist, and we're going to type in flattened.append the element. And at the end of this loop, we would just return the flattened list. And that is the most common way to flatten a 2D array. And if we actually go ahead and test this out, we can go ahead and say main, and I'm going to go ahead and copy in my three different arrays, so we can test them all out. So here we have the list of 2D, which has these numbers over here. Then we can go ahead and print the flatten 2D function with the list 2D inside it, since it returns a list. And when we run it, we'll get 1, 2, 3, 4 flattened. But this does not work with a 3D array. If we try to do a 3D array, it's only going to go one level down. So it's going to get rid of the outer brackets, but it's not going to go all the way down to 1, 2, 3, 4, 5, 6, 7, 8. And what I showed you here can be also considered a bit ugly because we are in the generation of list comprehensions. So if we comment this out, we can go ahead and say that flattened is equal to the element, which is the return. And that is for the sublist in the input list for the element in the sublist. And usually list comprehensions tend to become a bit confusing after a certain point, but the easiest way to look at this is to say this is the return for sublist in input list for element in sublist. And if you look at it, it's nearly exactly the same syntax as what you find down here, except instead of writing append, we just have element at the top. So that's one of the easiest ways to create list comprehensions. It's just to copy what you would do for a for loop, except put it in this kind of formatting. Once you understand how the list comprehension works, go ahead and just put it back to the one-liner so it looks nice and run the program, and you'll have an identical output. Now let's go ahead and create something that can flatten a 3D array. So def flatten underscore 3D, and we're going to take the same input list of type list, which will return a list. And we're going to do the same thing as from earlier. So we're going to start with a flattened array, and we're going to go ahead and type in for sublist in input list. And since we are dealing with another sublist, we need to go ahead and type in for sublist 2 in sublist. Now we are 2 layers deep, which means we can actually go ahead and finally access the element in each one of those sublists in sublist 2. And then we need to go ahead and call flattened.append and append the element. Then we can go ahead and return flattened. And now this works with 3D arrays. So as you can see, it's a lot of syntax for flattening lists using vanilla Python. And if we go ahead and try to print that, we can go ahead and print, let's say flatten 3D this time, and insert a 3D list. So now any kind of list that has 3 brackets can be flattened down to a single bracket list. As you can see, we removed most of the brackets, and this also works if we decide to, let's say, remove these two brackets here, and it's kind of weird. It still works the same way. It flattens it down until it is only one bracket. And I'm also going to show you the list comprehension alternative to this, although I think for this one it's a bit ugly because it's really big. So let's go ahead and try it. So flattened is going to equal, as always, the element, which is the first, for sublist in input list, for sublist 2 in sublist, for element in sublist 2. So that's how I like to write list comprehensions, or at least to make sense of them. As you can see, it was an exact copy of this. And when we run the program, we'll get the exact same output. And you can always go ahead and just fix that at the end. It just helps make sense of the list comprehension sometimes. Although this one is quite a long line, so it can be quite difficult to debug in the future. So I would more or less try to avoid anything longer than this, because as you can see, it's quite long. But it does look nice as a one-liner if you want to have a one-liner. And it flattens any list that is 3D. Now, you might have guessed that flattening a 4D list would follow the same approach, and this would become ridiculously long in a list comprehension, let alone for a for loop. And we don't want that. Although you can do it that way and there's nothing wrong with that, I'm still going to show you an alternative. And the alternative isn't perfect. It actually has a lot of limitations, but it is worth keeping into account that you can use it. So here we're going to go ahead and type in flatten any, since we can flatten any list, and it's going to take an input list of type list, and it's going to return a list. Now the syntax for this is so much easier than the rest of them. Here we're going to go ahead and first create a Numpy array. So here we're going to go ahead and type in Numpy array. And inside the Numpy array, we need to insert the input list. So now it's converted into a Numpy array. Then we can go ahead and type in flatten is going to equal the np list dot flatten, and we can return flattened. So this was ridiculously easy to write. As you can see, it was only 3 lines, and it could even be a one-liner if you combine flatten with this part here. So it's incredibly easy to create. And it's also incredibly easy to use. So if we go ahead and print the flatten any function with the list 4D, we're going to have everything flattened perfectly. And as you can see, there is one problem here, and that is that we don't have a list of them. We just have them all written out. And that's because I forgot to add list here, and I even got a type hint error. So once we do that, we'll get the same output as the rest. And this works with list 2D as well, and also 3D. Now, I was talking about limitations with this, and that is that this has to be perfectly uniform. Everything has to be more or less in the same kind of bracket group. So you have 1, 2, 3, 4, 5, 6, 7, 8. You can't have 7, 8, 9, because you'll go ahead and get an error from Numpy that this is becoming deprecated, and it's not going to flatten it either. So you need to make sure that it is uniform. And that also goes for if you have one group that's different than the others. Numpy is still not going to be happy with that, and it's not going to flatten that. And the final issue you're going to have with Numpy that you might have to fix in a different way is that if you have something such as a string, it's going to convert all the elements in the array into a string, or even if it's just a float, it's going to convert them all to a float. So there are a lot of unexpected behaviors you might encounter with the Numpy array, while with the for loop approach, you can insert any kind of item. This can be Mario, and this can be 6.0, and it's still going to flatten it as you would normally flatten a list. And you can have any kind of style here. So you can have 1, 2, 3 Mario, and you can have everything like this again, and it will still flatten it perfectly. So those were the basic ways that we could flatten lists in Python, but that's actually all I wanted to cover in today's lesson. So as always guys, thanks for watching, and I'll see you in the next lesson.